Hi everyone, Mrs. Vara here. So today in class, well, I am not in class. You're going to be working on this Exploration 3.3b. The 3.3 does not necessarily apply to our 3.3. This is more of a 3.1, 3.2 activity. Derivative graphs from function graphs. So the objective is to, given a graph of a function, sketch the graph of the derivative. So we're sketching the graph of the derivative. For each function given, sketch the graph of the derivative function. Locate x-intercepts on the derivative graph by recalling that the derivative is 0 if the tangent line is horizontal and has a high or a low point where the derivative is steepest. Show the behavior of the derivative graph where the given function graph has a cusp or a discontinuity. So I would say this is definitely a 3-2 activity because they're talking about cusps and discontinuities, right? These are the points that were talked about a bit in 3-2, the points where a function is not differentiable. So I'm going to do number 1 with you, and then you in class today are going to do 2, 3, and 4. And we're going to put the derivative graph right on the same coordinate grid with the function graph, just like we did when we did that one together in class. So I always want to start with finding out where my horizontal tangent lines are going to be. And just like they explained up there, they're going to be where you have a max or min. Always. There might be other ones also, but for sure where you have a max or min. A tangent line drawn at this point would be horizontal, and the slope of that tangent would be 0, so the derivative would be 0. So at this x value, which looks like -1, -2, -3, -4, so at x equals -4, the graph of my derivative is going to be equal to 0. Also at x equals 2, the graph of my derivative is going to be equal to 0. Okay, so now we just need to think about what's happening in this region to the left of this 0, what's happening between these two zeros, and what's happening to the right of this 0. So this would be what's happening when x is less than -4. This would be what's happening when x is between -4 and 2. And then last, what's happening when x is greater than 2. I'll put that one over here. So x is greater than 2. So all we have to do, that's a little hard for you to see, there's the regions we're looking at. All you have to do is figure out in these areas, is the derivative positive or negative? So I'm just going to draw a little kind of a vertical asymptote here. So I'm looking over here to the left of that dashed line I just drew. So picture drawing tangents on my function over here. That one's clearly going to have, that line's going to have a positive slope. Positive, positive. These are pretty steep down here. But I know everywhere where x is less than -4 that my derivative is positive. So I know I'm positive, I'm very steep, but then I know I'm headed towards 0. So I'm steep, getting a little less steeper, and then I'm 0. So I'm going to say I'm steep, but I'm headed towards 0. So something like that. Remember, this is a bit of an estimate. Okay, now I'm here at 0. So I need to see what happens between these two zeros. So on my function, I'm up here. And then my function is decreasing, right? It's at +10. And then at x equals 2, it's down here at y equals 2. So it's clearly decreasing. So here I have my tangent has a slope of 0. And then if you think about tangent lines along here, they're hard to see. But they're very clearly lines with negative slopes, right? They would look like that. Let me draw them out a little bit so you can see them. Negative, so negative, and once again, headed towards 0. So this is a little less negative until I'm 0. So I'm negative, and then I'm headed towards 0. So I'm right back here at this point. Okay, now all I got to do is look at x greater than 2. So right here at x equals 2, horizontal tangent. This is what a tangent would look like here, here, and here. So these are all lines that have a positive slope. They start out not that steep, but they're getting steeper. So then I'm increasing here. I'm definitely positive and I'm getting steeper. Okay, so you could, doesn't really matter how far you make it go up, but that is the graph of f prime. So I'm just going to darken it in a little bit here. Have to have these 0 points, have to be positive to the left of -4, negative between -5 and 2, and positive to the right of 2. So this is, if we're calling our original one f, this is f prime of x. And notice the original graph was kind of an x to the third-ish, up, down, up, that's like x to the third-ish. And my derivative graph very much looks like a parabola, so x squared-ish. Okay? So try 2, 3, and 4 on your own in class. Definitely answer number 5. This will be due on Tuesday. We'll write it right up here. Due Tuesday, 10/24. I'll take questions on it, but really what I want to see is I want to see it done on Tuesday, 10/24. This should not take you the whole class period, so you should have time to work on either 3-2 homework or 3-3 homework. Or if you haven't watched 3-3 videos, you should watch those in class, and then you'll have to do the homework at home. Okay, that's it. Thanks. See you tomorrow.